Hey everybody, it's Mr. Carr again. Today we're going to be looking at 1.4 day one, talking about extrema and average rates of change. Okay, so we're still analyzing our graphs of our functions here. We're talking about them in terms of determining intervals in which the functions are increasing, constant, or decreasing, and then determining maxima and minima of functions. Okay, day two, we'll talk more about what's called the average rate of change. So that's going to be for the next one there. So first of all, let's talk about what does it mean to be increasing, decreasing, and constant. So these are our formal definitions. A function f is increasing on an interval if and only if for any 2 points in our interval I, a positive change in x results in a positive change in f of x. So what that means is if I look at x1 compared to x2, which means I'm going left to right, is the f of x1 leads to a higher amount for f of x2. Okay, and that's what happens here. So as I go left to right, is the graph increasing? Okay, decreasing intervals, we kind of flip that. I'm still going left to right. X1 to X2 is left to right. But now what's happening is f of x1 is a larger value, and then it gets smaller when I get down to f of x2. So that's our decreasing function. The last one is constant. If I go between two values, x1 and x2, the outputs of f of x1 to f of x2 are actually the same. That's what it means to be constant. It does not change. It does not increase and it does not decrease. It just stays the same then. So that's our definition for increasing, decreasing, and constant intervals. So now what we're going to do is we're going to use that to help describe some of the behavior of our graph. So we want to use the graph of the function f of x equals negative x to the third plus x to estimate intervals to the nearest 0.5 units on which the function is increasing, decreasing, or constant. Okay, so what we can see, I can do a rough sketch of the graph right here. Again, we always go left to right. So my first interval is this one, and it's going to take us to about right here. Then it turns, and now it's increasing, and increases to about this point here, and then it turns one more time and goes down. So really, I'm looking at these 2 points here, like that's the local minimum and local maximum. This is decreasing interval. Then it's increasing right in this little spot here, followed by a decreasing interval again. So for us to be a little bit more exact, we're going to want to use our graphing calculators. So I'm going to go ahead and put this in a Desmos and bring it right back in just a second here. Okay, so here we are back in our graphing calculator. Again, it's however you want to do it, but the key is you're going to graph it. You need to find these minimum and minimum values. The numbers that are important are the x values. That's the only thing that we care about in terms of describing our intervals. So you notice the first x value is a negative 0.577. We're going to round it off and make it negative 0.6. Okay, we're just rounding off to 0.5s there. Okay, and then we have the other x value is 0.577 or 0.6 there. So those are the only numbers that are important. It's the y values are not necessarily important for our cases. So again, however you find this, I like Desmos, but feel free to use your TI-84s on this one. Okay, come back here. So my we'll start with decreasing because that's the first thing that happens to the graph. It's decreasing from the interval of negative infinity up to a negative 0.6. Okay. So that's what's happening to that one. Make sure that looks like a 0. This is describing it from here to here. And again, this is the negative 0.6. Okay, that's the x value. Then it's increasing. Okay, my increasing interval is going to go from a negative 0.6 to a positive 0.6. That is just describing this right here. And it's only the x values there. After that, it's decreasing one more time. So it's going from here to here. So we're going to do a union because we have one more interval. It's going to go from 0.6 to infinity. Okay. And that's it. That's our increasing versus decreasing intervals there. You notice how we have multiple decreasing intervals because it depends on how many times the graph curves. Okay. So again, by definition, the graph goes left to right. This part of the graph is going down. As I go left to right, this is going up, and that's going down. So we just want to make sure we are labeling those intervals correctly there. So make sure you understand a few more of our terms. We got symbols with our graphs here. Let me zoom out a little bit so you can see some more. A relative maximum of a function is the greatest value can attain on some interval of the domain. So this case, we have a relative maximum here and here. It's basically what's the top of the hill for that maximum. Okay. If a relative maximum is the greatest value a function can attain, is also called the absolute maximum. So for example, this one is an absolute maximum because that's the highest the graph goes. Okay. These are both considered maximums, but they're both relative maximums, whereas this is an absolute maximum when I look at that one right there. Okay. When I look at minimums, it's the same idea. These are the lowest points of our values here. They're both considered to be relative minimums. It's the lowest point that my f of x hits on the graph. But if it's the lowest point, like this one right here, that's going to be my absolute minimum. Okay, so that's why the f of b is the absolute minimum, whereas they're both considered to be relative minimums there. All right, so we want to look at this one again. Here you got one more. Approximately to the nearest hundredth, the relative or absolute extrema of our f of x equals x to the fourth. State the x values where they occur. Okay, so again, we need to use graphing on this one. It's very difficult to see this on here. We're not going to be able to solve for it. So we want to graph the function, adjust the window as needed so that the graph's behavior is visible. So I'm going to go ahead and go back to my Desmos. I'll be right back on that one. Okay, so now that we have our graph here, again, we're finding those maximums and kind of absolute maximum minimums and relative ones. So what I have, thankfully, I have these points that I can go on here. Different process with your TI-84. I think it does a little faster with that. Key is we want the x values. We get a relative minimum at negative 1.5. So that's this first one right here. That's going to be a relative minimum. I get a relative maximum right here at negative 0.2 for x. Then I get the absolute minimum here at 1.7. And there is no absolute maximum because the graphs are going to go up forever. Okay, so I come back here. I got a relative minimum at x equals, I forgot what number it was, negative 1.5. Okay. Oh, well. Relative minimum at x equals negative 1.5. A relative maximum at x equals, that was negative 0.2, I believe. And the absolute maximum at x equals 1.7. Again, that's describing these 3 points here for our relative and absolute minimums and maximums. Okay, and that is going to be it for today. So again, we looked at our maximums and minimums. What does it mean to be a little bit different between relative and absolute? And we also looked at our increasing versus decreasing versus constant intervals. All right, take care, everybody.